Okay, so this is the, I believe, the fifth video in the series of modeling the uh, frame structure, reinforced concrete frame structure, which has a beam and column. Okay, so we will continue with our next module, which is the step module, because we have assembled our model, and now we need to. By the way, we have not completely assembled our model, because I want to, do some. Uh, I want to let you guys know some additional details later. Okay, so anyhow, let's just assemble it for the moment. Can shift it here, and it's okay. Okay, so this is how we got our model. So now, in the step module, we will discuss the different details that you need to keep in your mind while doing your analysis. So, clicking on the step manager, here we have the initial step. It's by default from the ABAQUS. You cannot turn it off, or you can, if you can click here, so it cannot be suppressed, so it is by default. What we can do, we will create our new step, and here you need to give the name of your step, whether that is, it is a time history analysis, it is a monotonic load, or it is a cyclic load, or it's displacement based loading, or what else. So let's just give it as, let's suppose I'm applying monotonic loading. Okay, so this is my step, and here from the procedure tab you can select either general or linear perturbation, but for our case we will choose general. Anyhow, I'll also go through the linear perturbation, which means you can carry out the buckling analysis, the frequency analysis, and some other stuff. The important here is that mostly I use as well is frequency analysis, where we need to identify the mode shape and the natural frequency of our model, so we can easily do it from here. But anyhow, in this case we will go and select our general, and in general, because I'm applying monotonic load, so I will select static general. In other case, if you are applied cyclic loading, or you are applying the time history analysis, so for that you need to select the dynamic implicit or dynamic explicit, depend on your situation, but mostly I use dynamic implicit for that. So for a moment we will use static general. Continue. Here, description, you can add any description if you want, and the time period for how long you want to apply this load. Anyhow, I just want it for 1 second, and I will tick this on, because it is including the non-linearity in your models. And the next is the incrementation. Either you can choose automatic or fixed. In some cases, for example, most cases I used fixed, but when my analysis is not converging, so I choose automatic in that case as well. So let's suppose choose fix, and it's always a good idea to choose a larger value for the maximum number of increments, because it show when you submit your job, the ABAQUS will perform the number of increment. So if your model is quite large and it has more elements, so also it depends on mesh size as well, so it will take too much time, and it will also perform too many increments. But I do not want my analysis to be stopped because of a maximum number of increments, so that's why I say, okay, you do 100,000 increments, but complete my analysis. And the increment size, let's suppose choose zero point 0.01. Okay, so uh, fixed mean if there is no problem with the convergence, it will complete the analysis in almost in 100 step, I guess, because my time period is 1 second and my total increment size is 0.01. It's almost 100 steps. And the other, you do not want to change these things because we will let these things by default in most cases, but in very few cases where your analysis is not converging, you can play with these things. But you also need to study these things separately and also need to know the pros and cons of each and every step you follow. Okay, so for the moment we will have this thing. And okay, so now I have created a static general step. I have also turned on the non-linearity in this. Okay, and I can dismiss it. Now the next step is I need to identify my field outputs and history outputs. The field output is something that you can identify to visualize your results. For example, your stress, strain, response, displacement, rotations, damages in your beam, compressive damages, tensile damages, all these stuff. And this is also where this is also the place where your ODB file will be generated. So click here. By default it has created our field. Let's edit this thing. And first the domain, okay, I will choose the whole model because I want to visualize my entire model, that what is happening in the model. And the frequency, yes, for every n increment I want. By the way, the increment frequency also depend on the size of your ODB. Okay, for example, if you use n is equal to 1, you mean that at every increment I want to visualize the result. So definitely it will require a lot of space. For example, if you use this, it might take you 5 GB. Your ODB file will be 5 GB, almost 10 GB, depending on upon your analysis on your model, your mesh, and all these things. Anyhow, if you just reduce the size here, for example, if you say, okay, I just want to visualize the result for first increment, and then with the increment of 10, so I just want to visualize the result. For example, you won't be able to visualize the result from 2 to 9 increments, and at the 10th increment you will visualize your results. But anyhow, because it's not too big model, I'll keep this as 1. And from here there are some pre-selected defaults. I do not want these pre-selected defaults, so I can just remove them and choose my own. Okay, alright. First of all, okay, I want my stresses response, and also I want my measure stresses for the whole model. And similarly the strain, okay, I want my total strain components and the equivalent plastic strain. By the way, if you go through the ABAQUS documentation, there is detail for each and every of these things, and you know how you can use that, what does all these things means. Also logarithmic strain I want. Okay, anyhow, also just displacement I want to, and I also want to rotational and translational displacement. Here we can also choose the reaction forces and moments. I just only want to visualize these things, by the way. uh, in the in the history output manager, we can select similar kind of similar variables, but for that we will get the data as output, where which we also can import to our Excel sheet for further processing. We can draw some different result. We will go through that in detail, by the way. Okay, so reaction forces in moments, and that's all. And another thing is that I want to also capture, because I have uh, defined my compressive and tensile behavior of reinforced concrete while I was defining my material. If you do not know what does that mean, you can just go back to the first video where I was defining my material, so you will came to know what does that mean. So that's why I'm checking the compressive and tensile damage as well, and also the scalar stiffness degradation from here. Okay, I think that's all. I also want output for the rebar as well if it's available. Okay, for the moment these are enough, I guess. By the way, you can come to the step module, and even you can come to any module even after you are finished with your modeling, because at some time you have to come to your step module. For example, if I'm using my history output, uh, to be honest, during the history output I do not want the details for each and every portion in my model. um, I will just specify some particular location, and at that location I need some details. For example, if I am applying force at this location, so I need to know the displacement at this location and also at these locations. So that depends on you, that at which point you need uh, you know for example, you need displacement at that particular point, you need acceleration at that particular point. So for the moment, because we do not have any particular points, we will have points after we mesh our structure. So we will come back to our time history manager later. Okay, so I think that's all for this video, and we will do the which I have discussed this thing, the history output. We will, because currently I do not want my history output for the whole model, because when I mesh my structure, there will be more than 100 or maybe 1000 of nodes, and it will give me data for each node, and that is extremely difficult to analyze and to find the point of your interest. So that's why I want to specify the location to that point, and I'll get to my history output step later after I just mesh my structure. Okay, so that's all for this video, and I hope you like it. If you are new here, please do not forget to subscribe my channel. Also, if you like the video, please press a like, and let me know in the comments section if you have any question, if you have any queries, or even if you want me to model anything for you guys. So you can just paste your drawings or your models in the comment section. And also, if you have any problems with your modeling, if it gives you any error, if you have any convergence problem or something like that, so you can let me know. Okay, thank you guys, see you in the next video.